In previous video, we learned prompt engineering. We discovered that writing a better prompt produces better AI responses. But today we are going one level deeper. I'm going to show you something that most developers don't realize. When we use ChatGPT, we are not simply sending one string. Instead, every conversation is actually a collection of different messages. For example, there are instructions that define how the AI should behave, how AI should answer. There are messages written by user, there are responses generated by the assistant. Together, these create the conversation that the model sees. Understanding these messages types is one of the most important skills in modern AI development. By end of this video, you will understand exactly how ChatGPT and Spring AI build and send these conversations. As Java developers, we have always built applications like this: input, business logic, and then output. Very straightforward. Large language models don't work like that. Instead of receiving only one input, they receive an entire conversation. Imagine talking to a human. If someone suddenly asks, "What about him?" Can you answer? Probably not. You need context. LLMs work exactly the same way. Every request contains context. Imagine you open ChatGPT. You type, "What is Java?" The assistant answers. Then you ask, "Who created it?" Notice something interesting here. You didn't write who created Java. You simply wrote who created it. Yet, ChatGPT understood that it in the question means Java. How? Because every new request contains previous messages. The model isn't reading one sentence, it's reading the conversation. Every conversation consists of three important message types: system messages, user messages, and assistant messages. Let's understand each one. System message defines the AI's behavior. UI message tells the AI what to do, what is the actual task. AI assistant message stores previous responses. Think of them as three different responsibilities. Together, they create a complete conversation. This is probably the most powerful message, the system prompt. Think of it as the AI's job description. Before the conversation starts, we tell the AI, "Who are you? How should you behave? What tone should you use? Should you explain like a teacher or a doctor? Should you speak like a financial advisor?" The system prompt answers all these questions. Notice something important: the user usually never see the system prompt. It's created by the application. The user message is the easiest one to understand. This is the actual question typed by the user. Every time someone enters text into your application, that text becomes the user message. In Spring AI, this is written as .user in the argument question. Notice that the application isn't deciding what to ask, the user is. The system prompt defines behavior, user prompt defines the task. Now comes the third message type: assistant messages. Many beginners think these are unnecessary. Actually, they are extremely important. Whenever the AI replies, that response becomes an assistant message. Why store it? Because future questions may depend on previous answers. Without assistant messages, the AI would forget the conversation after every response. Let's follow this conversation. The system prompt tells the AI to behave like a Java teacher. The user asks, "Explain Spring Boot." The assistant answers. Then the user asks, "Who created it?" Notice that the second question doesn't mention Spring Boot. Yet, the AI understands. Why? Because the entire conversation is sent to the model. This is exactly what Spring AI does internally. Instead of sending a single string, it builds a list of messages. Then it converts them into JSON. Then it sends them to OpenAI. OpenAI reads the complete conversation before generating the next response. Notice how easy Spring AI makes this. We first define the system prompt. You are a Java developer. or you are a Java trainer. Then we add the user message in variable question. Finally, we call the model. This code is much more powerful than using only .user method because it allows us to guide the AI's behavior before it answers. Today, you have learned how modern AI conversations are structured. You now know that an LLM doesn't just receive a single question, it receives a conversation made up of different message types. By using system prompts, you can define the AI's role and behavior. With user messages, you tell the AI what task to perform. And by preserving assistant messages, you give the model the context it needs to answer follow up questions naturally. In next video, we will build on this foundation and explore zero shot, one shot and few shot prompting. You will learn how providing examples can dramatically improve the quality and consistency of AI responses, all while keeping your Java code almost unchanged. Thank you for watching. See you in next video.